let's now summarize what we learned in the last video here regarding graphs and their derivatives. Right? Graphs and the graphs of the derivatives. Okay? So, first off, what we have is, so if f prime of x is greater than 0 on an interval, all right, what we learned is that the function has positive slope. If the function has positive slope, so that's, say, let's go back to this drawing. That's, say, this part right here, or this part over here. The function is moving upward, and if the function is moving upward, this is what we call an increasing function. So if f prime is greater than 0 on an interval, then f is increasing on that interval. Right? Hopefully that makes sense there. All right. Now, if it's not increasing, if the derivative is negative, oops. Right? If the derivative is negative, instead of increasing, we just say it's decreasing. Right? Because that would be, say here in this spot where the derivative is negative, the function is moving downward, right? It has a negative slope, so it moves down. Right? So positive derivative is increasing, negative derivative is decreasing. All right. Now let's look at something else here. Going to the second derivative. So if f double prime of x is positive on an interval, then f is what we called concave up on that interval. Right? Remember, concave up, this was that sort of smiling shaped graph, right? It was in the graph formed like a valley there, or I always think about like up is good. If it's good, you smile. Second derivative. Positive would mean concave up. Right? And likewise, let's duplicate this. Right? And likewise, if the second derivative were negative, then we would say that the function is concave down. Right? Negative, down, you frown when you're down, you know. That's sort of always how I remembered these. Right? So, another thing I wanted to point out on this, about these graphs, is something of a, sort of like a local maximum or local minimum here. So, on this blue graph here, these three places right here, these are what we call local maxima and local minima. All right? So we'll delve deeper into this, but what are these kind of points? What does it mean? Well, these two are sort of turning points of the function that lie in valleys. They're kind of like the bottom of valleys. Right? The bottoms of these valleys we call local minima, or they're both what we would call a local minimum. Right? This one up here, the peak of a hill, right? We would call that a local maximum, because the word local means nearby. Right? So nearby this point, nothing is bigger. Sure, something over here is bigger overall, but in this little neighborhood here, this is the biggest. Right? So I won't formally define those because we'll do that later. But just sort of remember these points here. So maybe we'll formally define it. Well, we'll define it with like a graph here. We'll say here, these 2 points are examples of local minima, or maxima, sorry. Alright, maxima is just the plural of maximum. Right? This one right here is a local minimum. Right? So once we get some more derivative techniques and are a bit more comfortable with it, we'll learn how to actually compute these things. But for now, we'll just sort of know conceptually what they look like. Right? But see if you could make any connection between the location of these things and the graphs we were just doing.